Okay, greetings again, everybody. This video is going to show you how to solve the second Head Start practice problem. We just did the one with the bike. Now we're going to do this one. Here we have a freight train is lumbering along a railroad track at a again constant speed of 16 meters per second. That's your V. It never changes. Now somehow, due to a signalman's error, a passenger train traveling in the same direction at 40 meters per second, somehow that passenger train is accidentally put onto the same track. Then, when the freight train is 58 meters ahead, the passenger train, the conductor, sees the danger and he puts on the brakes, causing the train to decelerate at minus 30 meters per second squared. Meaning he sees the freight train in front of him. He puts on the brakes when the freight train is 58 meters ahead. The conductor sees it. That's when he puts on the brakes, and he's going to slow down and hopefully avoid a collision. Then 200 meters from where they brake, there's a station where the track branches out into two separate tracks. So if they can go 200 meters without colliding, then they can branch off in different directions. Diagram the problem, which we'll do. Will they make it safely to the station? No, they don't. Heads up. If not, at what point along the tracks do they collide? I.e., I want to know X. And at what time do they collide? I.e., I want X and T. I know. Yes, they collide 106 meters along the track at a time of 2.97 seconds. Well, let's go ahead and approach this the same way we did uh, the bike problem. Let me just pause this for a second so I get everything set up again. Okay, so let's go ahead and let's look at the solution. Let's look at the diagram and let's go over it. Okay, so remember the freight train here in the diagram I've labeled F. Remember, it's moving at a constant speed. Okay. Now it's a little bit different than the first problem because I went ahead and I gave you the head start distance. The problem's a little bit easier than the first one. In other words, here you can see the freight train is 58 meters ahead of the passenger train. At that point, that's when the passenger train, which I've labeled P, that's when the passenger train begins to decelerate. It's moving at this initial speed of 40 meters per second. When the freight train is 58 meters ahead, passenger begins to decelerate, and will they collide before they hit the exit? Okay. Well, notice, and don't let this confuse you, notice the acceleration is negative. Well, we don't want to get all crazy with the negatives. I have taken care of this negative sign right here. Okay? So so you don't put in another negative when you plug in A. You don't do that. I put the negative sign right there. Because remember, when you have the VIT plus 1 half AT squared, well, A could be positive or negative. So if A is negative, why not just put it right there? So when you plug in a value for A, you just plug in the 3 meters per second squared. Yeah, it's not rocket science. That negative is taken care of right there. Okay? You don't have to worry about it ever again. So notice again, well, the passenger train begins to decelerate when the freight is 58 meters ahead. So that's your head start. So you don't need to calculate any distance for the passenger. We're simply saying, hey, when the passenger train right here, he sees the freight train 58 meters ahead, he puts on the brakes, he's going to decelerate, hopefully avoid a collision. So the total distance that the passenger travels, the distance x, is VIT minus 1 half AT squared. The total distance x, again, x is the same for each. For the freight train, that distance is d plus VT. Just green plus green equals blue. D plus VT equals VIT minus 1 half AT squared. So there it is. So VIT minus, and again, don't let the minus sign throw you off. Once I put this minus sign here, I'm done with it. The value for A is simply 3 meters per second squared. I've incorporated the minus sign. It's a lot easier this way. Again, I want to rearrange this to get a quadratic equation in t. So in this case, I'm bringing the 1/2 at squared to the other side. It becomes positive. The vit goes to the other side. It becomes negative. And then I have, that's why I have the 1/2 at squared plus parentheses v minus vi, close parentheses t plus d. Well, again, my coefficient 1/2 a is 1.5. V minus vi is negative 24. D is 58. What do? Solver. All right, so my coefficients are, again, the coefficient of t squared is 1.5. The coefficient of t is negative 24. The constant term, d, is 58. So 1.5, negative 24, 58. Go ahead to the solver. 1.5, negative 24, 58. And I notice I get, in this case, I get two positive roots. I get and again, I round to 3 sig figs, so I get 2.97 seconds and 13.0 seconds. Well, remember, now in this case, when you have two positive roots, which one do you use? Well, you use the shortest one. In other words, and we'll look at the graph in a second, but in other words, when you graph the two position versus time curves, those graphs will intersect in two places. But you always use the shortest time. So we're going to use the 2.97 seconds. So here again, so because we have two roots, I have a T1 and a T2. Well, again, the collision will occur at T1, the shortest of those two times. So I need to use T1, which is 2.97 seconds. So I know that they collide after 2.97 seconds. And how do I get the 106 meters? Well, that's my x. That's where they collide. And again, you can use either equation to get x. So x is d plus v times t1. You get 106. Now you can check it. You don't have to, but x is also vi t1 minus 1/2 a t1 squared. And notice you get the same answer, which we know we're going to do, so you don't have to check it. So they collide at a time of t1 equal to 2.97 seconds at a distance of x equal to 106 meters. Then I ask a question. If you solve this problem correctly, you get two positive roots when you solve the quadratic equation. Give a possible explanation for this, a physical explanation. Remember, possible. Well, what happens is if you graph the two equations, if you graph the, let me pause this for a second. Well, notice, if you graph, if you graph those two equations, the d plus vt and vit minus 1/2 at squared. The green is the one moving at a constant speed, hence linear with a positive slope. Then the blue, that's the one that's, in this case, the acceleration is negative. Well, notice they intersect at 2 points. That right there, that's the 2.97 seconds. Over here, that's 13 seconds. Well, what's a possible explanation is when they collide, the passenger train knocks the freight train forward, and then it collides with it again at 13 seconds. But physically, that's impossible, because for that to occur, at some point, the passenger train would have to pass the freight train. And so that and the idea is that this graph is based on the fact that A is constant. In the real world, once they collide at 2.97 seconds, once that happens, A is no longer constant. And so those kinematic equations no longer apply. So, but anyway, that's the idea. Well, maybe why it's possible. This shows you that physically can't happen, because that would mean that the passenger train, which is the blue, would have to somehow pass the freight train, and then they would collide later on. But anyway, but notice that's what you get if you graph. This is the quadratic equation, the blue, the VIT minus 1 half AT squared, that's the blue. The green is the D plus VT, and notice they have the two roots. But anyway, that's just so, and that's it. So the key is, understand the wording of the problem, and understand. Oops, I went back to the first problem. Understand. And again, if you can draw the diagram, doesn't have to be a work of art. We don't need to be Pablo Picasso, but you can make a basic sketch and understand what's going on. It makes the problem a lot easier. Because clearly from this diagram, D plus VT must equal VIT minus 1 half AT squared. Because again, they are both the distance x. Rearrange, get the quadratic, you're done. Alrighty, let me go ahead and get this video posted.